So if you're following along in the book on page 433, this is number 1. I've drawn it on the board, but we're going to work the problem here. The first vector, vector u, has an initial point of 2, 4 and a terminal point of 6, 5. Okay, so if I want to find the magnitude of this, or how long it is, that's called the magnitude, how long this is, the length of it. I can just use the distance formula. Now they give us a formula for magnitude, and it's in the book, but you look at it, it's just the distance formula. So as you think of it that way, it's not a separate formula to learn. You're just going, oh, well, I can use the distance formula to find a length. And if you remember the distance formula, we could label our points x1, y1, x2, y2. And if you remember, what you do is you subtract your two x's and you square them. And then you add in the two y values subtracted and squared. Okay? So I can just plug in the numbers. Here x2 is 6 minus x1 is 2. And then I need to subtract my two y values. My y2 is 5, and I subtract y1 of 4. And then I'm going to square that. 6 minus 2 is 4 squared. And 5 minus 4 is 1 squared. It's not picking up my writing very well. And then that's the square root of what? 16 plus 1 underneath there, which is square root of 17. That's the magnitude, square root of 17. Well, they wanted me to show these two vectors are equal. So another thing I need to do is check vector v and compare them. If they're not even the same length, we can't say they're equal. Probably they are, since they told us to show it. So let me do vector v. Vector v had initial point, it begins at 0, 0, and it ends at 4, 1. This is going to be easier math here, isn't it, because of the 0, 0? If I could label it x1, y1, x2, y2. And again, the labels aren't showing up very well, but if I subtract the x's, it's 4 minus 0 squared plus 1 minus 0 squared. And that's going to be what? 4 squared plus 1 squared? 4 squared is 16. 1 squared is 1. So 16 and 1 is 17. Did they end up having the same magnitude? Yes, because they're the same length. So at least we know they're the same length. Now, in order to know if they are the same direction, normally what we would do, but we're not that far into the lesson yet, is compare the angles they make. That'd be one way we could do it, but there's another simple way here to do it. What if they had the same slope? If they had the same slope, wouldn't that make them parallel? They kind of look like they have the same slope, don't they? They didn't draw them in the book where it was easy for me to count, rise over run, but we could do that. That's one way I could do it. Another way I could do it is to use the slope formula. So let's just do parallel. If they're parallel, they would have the same direction. So let's see, we're going to have to do the slope formula. Here's the first vector, vector u. And again, they could have asked us to find the angle and show that the angles were equal, but they didn't here. So for the slope, it's the difference in the y's over the difference of the x's. Bless you. Okay. So I'm just going to say that I had labeled it earlier, and instead of labeling it again, hopefully you've got that on your paper. This would be what, on the y's it's 5 minus 4 on top. And on the bottom, x2 is 6 minus 2. Remember, y is on top, x is on bottom. That'd be what, 1/4? Let's check vector v's slope. At a very basic level, this is something we can do to check that they're in the same direction. Okay, the difference in the y's would be 1 minus 0 on top. If I subtract these two y's, and I got to start with the same y. If I started with the second point on the top, I need to start with it on the bottom. 4 minus 0 is 4, so I get 1/4 again. They are in the same direction, and they're equal in magnitude. Magnitude is just a fancy word for how long is the thing, okay? So for vectors, there are a couple ways we could write them. We can express them with the initial point and the terminal point. And so let's look at number 5. I'm going to do 5, and then I'll let y'all go back and do number 3. Number 5, it has if you look at it, it has an initial point of 2, 2, and the arrow is going back to negative 1, 4. So my terminal point is negative 1, 4. I can describe it that way, but it's not maybe as helpful as maybe doing some other things with it. So one of the way we can describe it is in this form where you put, it's kind of like they call it if this is vector v, and that's what they call it, we can express it where it has its x component, but we call it v1 for the x component, and the y component would be v2. Okay? So how do we get these? We get them just by subtracting the x's from each other and subtracting the y's from each other. And we want to go from the terminal point to the initial point. Okay, so terminal point to initial point. Okay. All right. Now, if you look at the book, it looks a little confusing because they're going to call these points Q and P. Okay. So here, P would be, if I label these the way the book does, just so you can understand what they're doing, and then I want you to see that all they're doing is subtracting x's and y's. Okay. It's like sometimes just looking at the notation is confusing. They're calling this point P, so this is going to be P1 and P2. It's like this point has the first part and the second part of the vector. It's kind of weird. It's on page 425 in that blue box if you look at it. I want you to kind of look. It's like you would think they would call it, they would do something else with it. It's just a little strange. You got to get used to the lettering. And then they call the second point kind of like Q. Okay. So let me put a big P here and let me put a big Q here. This is the Q, the first part of the vector, and Q, the second part of the vector. It's still like an x and a y component, isn't it? It's like there's an x part and a y part. I don't really use this formula very much. I just kind of think about what's going on because that P1, P2, Q1, Q2 kind of confuses me. I would have thought that they would have done something different with it, and I'm not even going to tell you what I thought they would have done because if you're not thinking that, I don't want to confuse you by telling you, okay? So what you do is to find the first part of the vector. If we're going to write it in a form like this, and they use these little, it's like the inequality signs as the brackets. They're these kind of sideways V brackets. Here's how you do it. To get the V1 part, you say Q1 minus P1. You're subtracting the x's of the vector, basically, of the two endpoints to find the component form of the vector. This is what we're doing, finding the component form. Okay. So you're subtracting your x's. That would be what? -1 minus 2. You subtract the two x's, and you go from the end point to the beginning point, which would be what? -3. So if you're writing this in component form, your V1 here, the first part of your vector would be the two x's subtracted, and you would write it like that. I'll circle my answer in red. Oops, hitting wrong things here. Here's where I'm going to write my answer down here so you can see where I'm putting my results, okay? Now I need to find the y part of the component form of this vector. I want to describe it in one thing instead of two things, okay? So my V2, which is the second part of my vector, I'm just going to subtract the y part. So it's going to be Q2 minus P2 the way they've labeled it. And again, I don't care if you use this labeling. I think this labeling is a little confusing myself. You're just subtracting the y, so it's just 4 minus 2 if I start with the end point and subtract from the initial point. 4 minus 2 is 2. It just goes over here. That's how, when they say they want the component form of a vector, they want it written like this, where you subtracted your x's and you subtracted your y's and you just stuck it in there like that. You're just saying what's the difference between the two x values and what's the difference between the two y values. Okay, so on 27, they tell us we've got a vector u, and it is -6 and -8. And this stuff is very easy, okay? And you got a vector v, it's 2, 4. So they're written in component form. When they're written like this, somebody's already taken and subtracted the x's and subtracted the y's for us, and we're always glad of that. Okay, so now we're supposed to do some things to it. We can add these vectors together. If we want to add them, we just add the x parts together, and then we add the y parts together, and we get our new vector. It's that easy. So if I say, okay, for the x parts, which they call something else in the book, but this is the easiest way to think about it, I'm going to add -6 and 2, and that would be what? -4. And for the y parts, I'll do it in green just to show the separate parts. I'm just going to add the two y parts of the vector. -8 plus 4. -8 plus 4 is -4. There's my u plus v. Pretty easy, right? Pretty simple. I can do things like I can subtract the vectors. So for b, they want us to say u minus v. So I'm going to start with u. And make sure I get the right vector, first. U is -6, the x part of it is -6, and I'm going to subtract the x part of the v vector, which is 2. Well, -6 minus 2 is -8, right? Okay. And then for the y parts of the vectors, which they call P2 and Q2 in the book, but we're just going to say y parts of the vectors, we just start with u, which is -8, and we subtract v, which is 4. And -8 minus 4 is -12. There's a dot there that shouldn't be there, so if you're watching the video and saying, what's that dot, it's random. So that's all I have to do to subtract it. In C part, they want me to say, what's 2u minus 3v? I can take a vector and I can multiply it through by a whole number. I just have to multiply both parts of it. So for 2u, let me do that first. 2u would be taking the vector u and multiplying everything by 2 in it. So since vector u is -6 and -8, that's going to be -12 and -16. All right, if they want me to subtract 3v, let me find 3v first. That way I can just do the subtraction in one step. 3v would be 3 times vector v, which is 2, 4. It's like distributing that 3 to both parts, basically. That would be 3 times 2 is 6, and 3 times 4 is 12. So now if I want to do 2u minus 3v, I've already got that 2u calculated and that 3v calculated, and I can just subtract. Okay, so for the x parts, I'm going to say -12 minus 6. And then for the y parts, I'm going to say here, -16 minus that other y part, 12. Okay, and that -12 minus 6 is -18. And -16 minus 12 is -28. That's 2u minus 3v. Okay, so I'm supposed to take v, which is 2, 4, and add 4u to it. So try that and see what you get. I'll work it out here and then post the answer. Okay, so the d part, we would just follow through, do that math. I've shown it here, but I'm going to turn the video off because it's getting too long. Here's the answer to the d part. I did the 4u here and multiplied it out and then added it to that v.